Write a function fib_n that takes in an integer n and returns the n Fibonacci number. So here, Fibonacci numbers are a series of numbers that start with 0 and then 1, and where each number is a sum of the previous two numbers. So here, by default, we start with 0 and 1, and the next number is the sum of 0 and 1. So 0 plus 1 is equal to 1, 1 plus 1 is equal to 2, 1 plus 2 is equal to 3, 2 plus 3 is equal to 5, 3 plus 5 is equal to 8, 5 plus 8 is equal to 13, 8 plus 13 is equal to 21, 13 plus 21 is equal to 34, 21 plus 34 equals to 55, and so on. So here, the challenge would be to write this function in one line of Python code. So do pause this video and take some time to give this a go before taking a look at the answer. So as I always say, before we can write a function in one line of Python code, we need to be able to write it in many lines of Python code. And here we have two working multiple line solutions for our function. So the first uses a list, while the second uses a bunch of variables. However, we cannot really condense this into one line because we cannot really condense all of this into a single list comprehension. And same with here. So here, we have to find an alternative way to do our function. So let's get rid of this and let's use recursion instead. So define fib_n, and here I'm going to write a bunch of stuff first. So let's just take it as it is first. So here, if n is equals to 1, I'm going to return 0. So this is a default value. And if n is equals to 2, I'm going to return 1. So this is another default value. And next, I'm going to write this. Okay, so return fib_n minus 2 plus fib_n minus 1. So here, a function is a recursive function if it calls itself. So here, our function name is fib, and here we also have fib. So the function is actually calling itself. And so if we run this, we are going to get the correct answer still. However, if you are new to recursion, this might be very new and a bit confusing. So let's actually figure out how this works. So here, let's start with fib1. So if n is equal to 1, we simply return 0. So this is a default value, also known as a base case. So we simply return 0, and so we are done, nothing else. And next we have fib2, and similar story, we simply return 1. So there's no calculation, no nothing. So these are our two base cases. And next we have fib3. So fib3. So here n is not equals to 1 and n is also not equals to 2. So here we return fib_n minus 2 plus fib_n minus 1. So here fib3 is equals to fib2 plus fib1, because n is 3 and we have n minus 2 and n minus 1. So once again, fib2 is going to be 1 and fib1 is going to be 0. So this is 0 plus 1 is equals to 1. And next, let's take a look at fib4. So fib4 similarly is equals to fib2 plus fib3. So here, fib2 is just 1 and fib3 is going to be fib2 plus fib1. And as we have calculated just now, is equals to 1 plus 0 plus 1 is equals to 2. And once more, we are going to have fib5. So this is simply fib3 plus fib4. So fib3 will become fib1 plus fib2, and fib4 will become fib2 plus fib3. So fib1 is simply 0 and fib2 is simply 1. Fib2 is simply 1 and fib3 is simply fib1 plus fib2. So fib1 is 0 and fib2 is simply 1. So here we have 1, 1, 1. So our total number is going to be 3. So here, if we move on to fib6, fib7, and so on, we are just simply going to generate the Fibonacci number sequence. And so here, this is why our recursive Fibonacci function works. And since we have a multi-line function, now we can work on condensing this into one line of code. So here, if n is equals to 1, return 0, and if n is equals to 2, return 1. So here, notice that we can combine this. So if n is less than or equals to 2, return n minus 1. So this is with the assumption that we will not get fib 0 because that does not make any sense. And here we have a simple if-else block. And here, to condense this if-else block into one line, we can simply use the ternary operator. So return n plus 1, and let's cut and paste it in front of our if here. And let's have a space here. And here we have an else, and we simply put the rest of the stuff here. And let's run this once again. And we still get the correct answers. So here, our final step would be to put this in one line of Python code. And so here, we have successfully written this function in one line of Python code. So thanks for watching, and hopefully this was clear and easy to understand. See you in the next one.